Yeah, Kirtan, I'm audible. Hello, Kirtan, is it audible?
Yes, sir.
Yeah, Kirtan, so what I was saying is, okay, we are done with electricity mostly. Just electrical measuring instruments are left. Okay, so do you have any query, anything which we can cover before moving to this? Anything which you want to be discussed once again in the class? Yeah, Kirtan, I'm asking you. Like, so the last topic we are left, that is electrical measuring instrument. Let's start electrical measuring instrument today. So, Krishna, till now we have studied like what is current, what is voltage, and everything. Now we will discuss how to calculate. Calculation is also already we know, but what are the instruments by which in a real life we use to calculate? I'll start with electrical instruments. So there's basically two rules. Is electrical property. What is reflection type? Out of these three meters are galvanometer, uh, five experimental setup. So, okay. So this part is not to be discussed a lot. We will discuss first this. What is deflection? Deflection is basically any device which will tell you about the reading by deflecting. Okay. Deflecting means to say, let's say this is a meter. Okay. And have you okay? You can take an example of weighing scale, right? Electrical weighing scale. What happens? Electrical weighing scale. What happened in that? There's a small kind of cavity is there. Okay. Whenever you put your weight over there, there's a knob or something needle which moves from here to there, right? Depending upon your weight. So this is deflecting. Why it is getting deflecting? Because there is a point over here. From here, it is getting deflecting to by this angle theta. Okay? By some angle theta. This is what a deflection type meters. Okay. So out of this, we have to study three ones: galvanometer, ammeter, and voltmeter. Calvin. Get my- We need to discuss this measuring instruments part like a galvanometer, potentiometer, and all these things. Or you can do it by your own because this is not a very hard thing. This is an easy part. So if you can do it by your own, I will leave it up to you. If needed to be discussed, then let me know. I will discuss further. So what's your take on these parts? Like whatever the institution you are in part of, have you studied all these things earlier, or you are yet to study, or I need to cover? It's your choice. Okay. On the basis of that, I will go further. Out of too many things, if you want, like if you think you have already studied some parts and you want to be revise one of these instruments, so we can do that also. It's your choice. What we should do quickly, because it's not a very conceptual thing. So if we discuss that, so, okay, I can. Yeah, I'll explain. So look, we have first is galvanometer. What is it? It's a small device, a small a device basically. Device measures a small current. Before this, just type in the message to measure current, which instrument we use, and in which configuration, parallel or series, and for voltage, which instrument we use, and in which configuration. Just type that into the chat. What is the galvanometer? It is device which measures small current. So galvanometer has two standard characteristics. Okay. First is full deflection. Okay, and what is the configuration? You have to tell me the configuration. So, okay. Which one is parallel fitted and which one is rivet? Yeah, so basically these galvanometers are used in two ways. One is full deflection type, full deflection current, which is called as IG, and another is coil resistance. So on the basis of two characteristics are there. The, for a galvanometer, we have two characteristics, okay? Coil resistance. So uh, we are not now interested in making the galvanometer. So just assume galvanometer is nothing but a coil inside. Okay? We will discuss this in the upcoming chapters. So yeah, when I'm talking about the coil, it means coil has some resistance. Or when I say deflection kind of current, because it is measuring current. So what is IG full deflection mean to say? What is the maximum current it is going to measure? Okay? That is we are because it is zero here it is maximum, so you can say IG. Okay. So two characteristics are there. One is what kind of resistance is there for the galvanometer, or what is the maximum current we can measure. Okay. On the two basis of these things, we decide a galvanometer. So there is a two characteristics. Coil resistance, it is basically the resistance of the inner coil of a galvanometer. Resistance of the current is passed. So what? How we are going to measure current? This is a circuit. This is basically a branch from which current is flowing in this way. Current I. This is the maximum current, right? IG, which is going to measure. This is a coil. This is basically a galvanometer coil, and there's a further new branch. So in this coil, from here the pointer is showing you as a maximum value. Assume this is maximum value. Like 1, 2, 3, 4. This is galvan. 0 hygiene. Hygiene current is 3. So galvan there is pointing to this. This is one. So if you see carefully, when we connecting a galvanometer is connected in series. So whatever the current is passed through this branch, that is going to be passed through this. Okay. What about this galvanometer? It consists of some coil, okay, which is wounded wire. It has resistance. Okay. When it has resistance RG. So you can say this current is also passing through this RG part. Okay. Is it clear? Although in case of ideal galvanometer, this RG is equal to 0. Okay. But lab galvanometer, if this is A, G, galvanometer G, this is R. We assume that the resistance of it is along with it. This is not an external resistance. This is internal resistance of this galvanometer. Okay. That is correct. Yeah. Okay. What is meant by ideal? Ideal is basically I wanted to measure the current, right? But because there's a resistance provided by this galvanometer itself, so it will actually reduce the value. It is going to reduce the value by very small margin. Okay. That's why we call it as a. That's why we say that for an ideal galvanometer, RG should be 0, so that it won't dissipate small part of current. Okay? That is the thing. So let's see the animator next. What device measure current? Device measure current. And measure measure current series. It is using series. This ammeter voltmeter are made up of galvanometer itself. Okay, so they have some resistance R for ideal ammeter. Lab are basically normal. Lab is just written, but for lab or in general cases or real cases, the ammeter RA is have some value, some very small values there. Okay. Major instruction, if I talk how we make a ammeter, uh, a shunt resistance with galvanometer. Basically, how galvanometer measure the current. It's just a device, okay, which have a deflecting nature. So when you provide a current, you have a shunt resistance, okay, from which your current is going to pass. On the basis of that, you say current is passing through the resistance. Okay. So what I'm saying, I, okay. So I was saying about the um, galvanometer, how we can convert this galvanometer into the ammeter. For that, we need to apply shunt resistance along with this. Okay. I'm just writing this. क्या हो गया देना देखते थे कैसे okay so yeah what I was doing is shunt resistance okay. So you are given this shunt resistance you can call this as RS okay. This shunt resistance has a very small value. Why we keep it as shunt resistance? This shunt resistance is kept in a parallel with your galvanometer coil okay. For example this is a galvanometer coil. Just keep look what I'm saying. This whole thing is going to act as an ammeter. This is a galvanometer. I'll be providing a shunt resistance. Why this shunt resistance? Because it has some higher value. This galvanometer has some higher value. When you provide a shunt resistance, a very small value, most of the current is going to pass from here. When it gets passed from here, you are able to manage. You are because very small amount of current is going to pass. So you can say that you can measure a very high value of current by using a small amount of galvanometer. Okay? This is the use of galvanometer. Is it clear? Clear? Clear, right? Okay, Kirtan, can I do one thing? Can I speak you with NCRT itself? Because all these things are already given in NCRT with the proper figures. NCRT districts are not given. They are given in NCRT. These are given in the moving charges in magnetism as per the NCRT document. So, Yeah. So here I'll just explain this how the section goes. So look, what we do is we keep a galvanometer, okay, and there's a current of it. What I just told, you can't directly measure. When I initially said galvanometer is used to measure small current, the reason is we are not directly using the current using galvanometer. Okay? We use galvanometer, and along with this we use one resistance, which makes us enabled to measure either current or voltage. Okay? So because I wanted to measure current, assume this there is a galvanometer, it has a coil in it. Okay? So when you just pass current, what will happen? The coil has very high resistance. Okay? So it's not possible for you to measure exact amount of current. What we do, we keep uh, shunt resistance. The resistance of galvanometer is Rg. For this one, either you can S or you can call R. It's up to you. In general, we call it as just S. So the current I is what? That is fine. Um, let's make it a little bit big. Okay. This is whole of your ammeter. You can call this whole thing as an ammeter, and you are connecting the whole ammeter in a series with the circuit branch. Now, I is the current, total current which is going. You can see out of this I, one portion is going to go here, another is going to go here. Ig is the current which is going passing through this galvanometer, and what is the rest of the current? I minus Ig. This is the rest current which is passing through shunt resistor S. So if you have to equate some equation, how you can equate the equations? You can simply say potential along this and this is same. So what is how you can say? If I say this is A point, this is B point, what is the potential across this? BA minus VB. Can I say we just go from start from here A and B? How you are going A minus going into direction of current and RG. You reach VB. Okay. So what is VA minus VB? That is IG and RG. This is one thing. For VA minus VB will also come out as I minus IG times of S. Okay. Look at now. In some books, you will find resistance of galvanometer is given as G and somewhere it is RS. In some books, shunt is given as RS and this and S. So these two things are there. Here we are going to use this configuration of G. G means resistance of galvanometer, resistance of shunt. Okay. This is what we are going to use. So yeah, instead of RG, I'll use G itself. It will do. So you can say I can equate both of the equations. So when you equate Ig into G comes out as 1 minus Igs. Okay. So what is shunt? Shunt comes out as Igg divided by 1 minus. This is an equation. Basically, you can solve it. You can like rephrase the equation as per your requirements. Assume you wanted to calculate Ig current. So what you can do? Simply just change whole of the equation. Okay. So yes, what are you going to do for the Ig? That will come out as total current divided by sorry, total current multiplied by the shunt, okay, divided by what is it? I plus the G plus G plus. If you have doubt in this, how we came up with this, this is a very simple thing, right? We are having two different resistors, RA and RB. So I am asking you, total current is I1. This is total current is I. So what is the portion of current passing through this? You know, we simply do this. Total current multiplied by resistance of opposite one divided by what? Sum of two. Here also we are doing this. What is current passing through this? That is IG. And I want to calculate IG. Total current I, opposite one S divided by sum of two. This is basically current divider rule. Came from the current divider. Is it clear? Is it clear, Kirtan? Yeah. So I just wanted to give you a small story again. If I ask you what is the resistance of the total ammeter, look, this whole is an ammeter, right? What is the total current? You can see in this ammeter you have G, you have S. So total animated. They both are in the series, right? So you can say GS divided by S plus. Both are the parallel. So this is the result of total animated. Okay? If I ask you what is the range of animated, so range is basically what is the maximum value you can use, right? Can I say this? So that IEG, what can be the maximum value of IEG that is going to be a range? What you can do is simply reduce the value of S and you will be able to use it. What is IEG? You can increase the value of this I because let's see. This is the maximum current you are going to measure. This IG is basically the part of current which is passing through this galvanometer, right? But at the end of the day, you are measuring this, right? You wanted to increase the range. So when you decrease this value S, okay, you will be able to increase this value. Understood? That is what you have to do. So this is what is all about galvanometer and ammeter. We are left with voltmeter. So I think I will end the session by this. Okay, Kirtan. In the next class, I will cover the voltmeter, complete voltmeter, and some potentiometer and some other measuring instruments. Is it fine? Do you have any kind of doubt and queries? Okay, any kind of doubt and query which you have? No query, right? So I think by this I will end this session, Kirtan. Today class was not for so long, but still no problem. Will in the next class you will see. Okay? Yeah, yes, goodbye. Okay? If you don't have any doubt, Kirtan, you can leave the session. Like you can enter yourself.